All right, I'm ready. And 5, 4, 3, action. Good evening, everyone, and welcome to the Chicago Cloud Computing User Group. I'm really happy to see you all here today. We have an excellent presentation today. It is with Mary Gragleski is going to present on event streaming and multi-agent AI for cloud-native architectures. And I created slides this time for the first time in the 6-month genesis of this group. Let's see how that goes. I wanted to remember to thank our sponsors. ResponsiveX is here tonight. They, as always, have bought our pizza. Big hand for the guys that bought our pizza. Thank you, Eric. Thank you, April. Microsoft, I work for Microsoft. My name is David. We provided the space here, and we showed up, which is cool. I wanted to talk, we mentioned this last time, is that we're inviting people to do lightning talks. And a lightning talk is a short, under 10-minute presentation that you can deliver on any topic you want. So you can just stand up here, you can show slides, you can show demos, or you can just talk. And it's a great chance for you to get some experience in public speaking if you haven't done so before. Nice low-risk thing. If you're not sure if you like it, if you're not sure if you're good at it, give it a try. I really encourage you to do so. The absolute worst-case scenario is you wasted 9 minutes of our time, which is not really all that bad. And so I really would encourage to try. I used to run a user group back in Michigan years ago, and a lot of people who started out doing lightning talks ended up speaking later on, doing a full session at the user group, ended up speaking at conferences, some of them at conferences all over the world. It's kind of a gateway into the world of speaking, just to see if you like it. So if you want to do that, talk to me or talk to Eric in the back here. He's waving his hand right now. And let us know that you're interested, and we'll get you on the calendar. We have one scheduled for today, and it will be given by me, just so you get an idea of what a lightning talk is. All right, you probably have been here before, but our website is the Meetup site. We have the URL chicagocloudug.com will take you there. I encourage you to go there. You have to register at that site to come to the meeting. We do have one issue that's still an issue, that if you don't have your full name in your Meetup profile, then we don't get your full name. So I would encourage you to go back and update your profile, put your first and last name in there. And the reason that's important is because the building security needs your full name in order to get you in the system so you can get in really easily. Most of you did this. You walked up to security, you said, hey, my name is David, and they looked you up and they gave you that little badge. But if you're not in the list, then they have to call me and I have to call in and it's another one. It slows everything down. So it'll make it easier for you, it'll make it easier for me, and it'll make it easier for the building security if you have your full name in there. Are there any people here attending for the very first time? Please raise your hand. How did you hear about it, Dwayne?
I saw Mary's face pop up in my email box.
So Mary told you?
Yeah.
She emailed you?
I didn't tell him.
I think you invited me to this a long time ago.
Oh, good.
And I've
All right.
subscribed.
All right. Who else is new? Somebody over here. Yes, sir, right there.
A friend of mine told me about it.
Say it again?
A friend of mine told me.
Your friend told you. Is your friend here tonight?
No, he's not.
So he didn't come, but you came. All right, another word of mouth. Who else was here for the first time? Yes, sir.
I am in this same situation. A friend told me about it.
And then bailed on you. Got it. All right. A word of mouth seems to be the way. Oh, gosh.
We were part of the same Teams channel, so that's how I.
All right, so I posted it on our team chat. So it sounds like word of mouth is the way to get this out. Every single person that responded said, my friend told me about it, or a coworker told me about it. And so if you like it here, I encourage you to do the same thing. Just tell your friends, tell your coworkers, let them know that there's some interesting things happening here. We would love to grow this group beyond what it is. You can see the capacity we have here. We can seat about 110 people in this room. And we'd love to get there. All right, we have some great presentations coming up in the next few months. Dale Wayne will be here next month, talking about what isn't your system supposed to do. And then in January, Tim Rayburn is coming up all the way from Dallas, Texas, to talk about, I copied that wrong. That's not, they're not going to be the same one. It's something about AI. There's a typo in here. But anyway, we have two presentations, one in December and one in January. We've got them scheduled. Those are the dates. What's that?
I think it's MCP.
It's on MCP, yeah. Who created this slide anyway? All right, let me switch over, and I promised a lightning talk, so I'm going to do one now. Somebody, Eric, will you keep me honest and just tell me when there's, 5 minutes have gone by? Let me find my, here. And starting now. All right. Hey, I want to share something that I just recently learned about. There's a product called Microsoft Playwright, and I wasn't even aware of it until a few days ago. Somebody asked about it, so I wanted to pretend to be an expert. I studied it really fast. It's designed for user interface testing. Testing, of course, is a big part of software development. And, well, that's me, by the way. I'm David. And this is a Node.js library that allows you to test the user interface. Usually when somebody wants to test a user interface in an application, you hire somebody of your testing team has to sit down at the computer and click buttons. You enter something in this text box, select from this drop-down list, click the submit button, verify that no errors occurred, verify that it navigates the correct screen, that the text on the screen is the same. It's a very manual intensive process if you do it that way. Well, you can automate that with a tool like Playwright. What Playwright does is it allows you to record those actions when working through a browser-based application, turns it into code, and then you can play that code back and it'll emulate a browser, it'll emulate a device, and you can then integrate that with whatever your testing framework, whatever your automated testing framework is, and then even make it part of your continuous integration, continuous deployment process so that every time you deploy, it automatically includes these tests along with your unit test, your integration test, and so on. It's pretty simple. It is a Node application, so you need to have Node installed to use it, and you need to have some sort of IDE, like Visual Studio Code is the one that I use a lot. It's simple to install. This line right here, npm i-d playwright. It took like 30 seconds to install this. And then with this line right here, npx playwright, code gen, and then the name of your site. You don't need the name of the site, it'll just open a browser, a blank browser. But if I put the name of the site, it'll actually open that site. That happens to be my blog right there. And then you can start, with your keyboard, with your mouse, start moving around and doing the actions that a user would do with your application. And it'll generate code. You can actually see the code being generated, and you can also do some assertions to say, oh, does this text box display this text? Is this image visible on the page? Did I navigate to this page? So just like in any testing framework, you can have assertions, and if those assertions fail, then your tests will fail. All right, that's my slides. Let me show you a demo, which means I have to change the screen that I am sharing here to duplicate. And Ron, can you see this screen now? No. Okay, let me share my screen for the remote audience then. Share the screen. Share. How about now?
Yes.
All right. And I want to hide this thing too. Hold that. Hide floating menu controls. There we go. Okay, so what I can do is that I told you about this command right here. I've already installed this, so I am going to run, where did it go here? This is the URL. I've created a form right here. I use Microsoft Forms. And in here, if I go into my browser, this is a form just ask some questions. What is your name? What is your quest? What is your favorite color? Now this crowd, some people are laughing because they recognize that you must answer this question 3, error the other side you see. And so I am going to do this line right here, but with that URL, and tell it to bring that up in an emulated browser. So I'll go into my terminal window here and run that. And what you'll see is this browser will pop up here with that form. You see there's a little colored bar indicates where my cursor is right now. Let me move it aside because we'll also get this code right here. So if I click on a bit of text, you can see that it's writing code. It went to the page, it went to that text. I want to go to this one right here. What is your name? Why, I am Arthur, King of the Britons. Oh, I didn't elect you. What is your quest? I seek what? The Grail. And what is your favorite color? Blue. No, green. And then I submit. And you can see that code being generated right on the left side. Let me scroll down a bit. Click that right here where it's selecting text boxes and radio buttons and so on. And if I want to, I can also, and then this correctly redirected me to this page, and I can add assertions too, right here. If I go down to assert visibility. So I'll click on that and say this button right here. I want to make sure that button is visible. You see that. Await expect page.getByRole. Minimize that right here. And this button, save my response to be visible. Or I can also check to see, click this button and say this your submit. I want to make sure that that text right there, expect page.getByLog. So all this information here this is code being written. And there's a whole object model. You can modify that code if you want to. But what I want to do is just stop recording and copy all that and paste it into my project here. I've got a test project that I've opened up right here. And in fact, I've actually already did this. Right before the meeting started, I did this test right here. And this is essentially the same stuff that I recorded. It went to the page. It did all the text and typing and clicking and all that stuff. That's all emulated right here. And there's my assertions down at the bottom. And because I'm using the in-unit test runner, it's actually got, I didn't show you this up here, but actually in here I can specify what kind of code do I want to. Do I want to run it under MS test or in-unit or JUnit? I can modify that. If I switch it to JUnit, for example, it'll write Java code decorated with all the things that JUnit requires. But I'm using NUnit here, and then I can just simply compile that code in my terminal window over here. I don't know if you can see that, but where's my terminal window? Terminal. Whoa, got dark all of a sudden. Dot, that's not working. Why is that? There we go. .NET build to build this project, and then .NET test if I'm using NUnit, and it'll run this one test right here, this decorated with the test attribute. It'll test those two assertions at the bottom, and you can't see it, but there was a browser that ran invisibly. It went through all these clicks, all this typing, and it said a total of one test matched by this platform. It's still running. Come on. There we go. And it says passed, failed. You look down here at the bottom. It passed, failed, 0, passed, 1, skipped, 0. So then I can add this to my build process and say run these tests every time you do a compile before you deploy out to production or some other environment. Add this extra set of tests to it. And that's it. That's Playwright in a nutshell. That's my lightning talk. Thank you. How did I do for time?
Great, you got 2 minutes.
All right, cool. I'm going to use those 2 minutes. Oh, thank you very much. To introduce our speaker here. Our speaker is Mary Grygleski, and I will stop. Come on up here and connect while I'm talking. I first met Mary in Sandusky, Ohio, and then a few months later, where she was speaking at the CodeMash conference, and a few months later, I met her in Kansas City. She was speaking at another conference, and then I met her at another conference. I quickly realized that she's speaking at all these conferences all over the country, all over the world, and that she has, she's an internationally known speaker. But more than that, she does a lot locally here with the local tech community. She's running the local Java user group, the AI collective, and she has her hands in a few other things as well. So she's been a great supporter of the tech community here in Chicago and worldwide, and I'm proud to say she is a friend. And please give a warm welcome to Mary Grygleski.
Thank you, thank you.
Why don't I give you this?
I probably need this. I don't speak as loud as you do.
Well,
Make sure I got this. Oops, sorry. So you have to be very careful. Oops. Hello. Okay, you can hear me, right? Yeah, okay. Well, thank you all for taking your time and tonight. And I think I saw that there are also other meetups too tonight elsewhere. So thank you for coming to this one. And thank you again to David and Eric for hosting me tonight. So let me kind of get set up too. If you can give me a second. Okay, I have this. And I also have, where is, oh wait, I'm sorry. I cannot find, oh, here we go. Okay. Okay, let me do it again. Let me, okay. Let me slideshow. Wait, I'm sorry. I can't, okay, sorry. Display, where's the display? Oh, sorry. Oh, of course. I didn't even plug that in, no wonder. I'm like, where is it? Yeah, because I had it earlier and then I unplugged.
And the Zoom as well.
That's right, and the Zoom, that's right. Okay, this one, okay, and then that one, okay. Sorry, okay. Let me move this over there first, okay. This one, okay, and let me slideshow, actually. Where's the slideshow?
It's on the right-hand side.
Yeah, that's right. Oh, that's right.
Plus, you need the share,
Yeah, that's right.
Zoom share.
Yeah, that's right. Let me, and this mouse, it doesn't work too good. For some reason, there's some delay when I'm moving it up there. So, okay, sorry. Okay. Wait. I want to get rid of that. And then, and where is my presenter view? Okay, well, I guess that's okay too. I don't need that, sorry. Okay, slideshow. Let me slideshow. And then I'll go back to Zoom and then share that on Zoom. That's it. Okay. Okay, can you see it? No, okay. Thank you all for your patience with me. So tonight's talk, I'll be talking about event streaming and multi-agent AI. And then because this is cloud computing meetup, so I figure, okay, kind of make it relevant for this group too. If you're coming in, there's got to be something to do with cloud. So it's really like cloud native that is what I'm going to be talking about. But first of all, before I start may I ask you, how many of you are already, let's say, working with, first, like event streaming? How many of you have work? Okay, great. So are you like working with Kafka or maybe like Pulsar, something like that? Yeah, which one? Kafka? Oh, Event Hub. Oh, Azure. Yeah, okay. Yeah. How about folks to other folks? I'm curious too. What kind of platform are you using? I'm curious. Like. Oh, also Azure Event Hubs. Okay. Yeah. Kafka. Yeah. Okay. So maybe a couple of Kafka and then Azure Event Hub. So yeah, that's kind of like similar type of approach, right, to solving problems with messaging. And how many of you are already, like, say, working with agent, AI agent, and multi-agent, agentic? Yeah. So a few. Okay. So I'm going to be having some introductory kind of things too that I'll be talking about. I think it would just make it more relevant for everybody too. And then also to how, cloud native ought to be, suited into this topic too. So, okay, so let me go. And now I can't get to it. Okay, here we go. Okay, so this is the agenda. I'll have a quick introduction and then agentic and multi-agentic AI foundations, some basic things. And then also to pointing out to some current like popular AI agents. Those are primarily like for non-programmers, more for no-code type of situation. And then I'll then get into more event-driven world and AI. Also, too, I probably would spend some time also getting a bit into like event-driven and distributed computing too. And curious too, anybody working with more distributed computing at all? Like these are like kind of more, like dealing with like data state, maintaining state and consistency, all these things. Anybody data pipelines? Yeah, so a few, okay. I just want to kind of get a feel too, because it might kind of get a bit too into some deeper end and may not be applicable, but I'll try to make it relevant for everybody. And then how distributed computing is, and the way I see it is that agentic AI can only become fully kind of useful if we get into distributed computing too, is what I think. And then primarily talking about data engineering, and then some cloud native principles for AI workflows, and then applying event approach to RAG as an example, and challenges of Gen AI. So that's the agenda. First of all, who's Mary? So I won't go into all the details. David already made a very good introduction, but right now too, I'm helping out the AI Collective. That's what I'm doing now. I'm also covering the global side of things too for them, for North America and Latin America. And we are also doing meetups too. And a lot of times, David actually help us if you've been to some of our AI Collective meetups. We have it here too. And the thing is, with AI Collective as such, we include not just technology people, but there are also founders or investors and business people, marketing, all kinds too. And if you are interested too, you can come talk with me if you want to do presentations or any kind of activities around it, workshops and things like that. And I'm also heavily involved with Java. I've been working with Java actually for a long time. And I'm also a Java champion, also run the Java users group too. So that's me. And then I kind of brought up distributed systems because that's actually how I kind of started studying math and then computer science, and really distributed systems is one area that I'm very interested in. And that's the way I see it right now, agentic AI, we need to bring in the distributed systems kind of aspect to really make sense out of it, to talk about, doing stuff that's beyond just user level. And right now there are lots of AI agents too, I agree, and they're very useful. For a lot of things using ChatGPT, doing kind of one-shot deal, kind of, so to speak. But to make it really useful for enterprise, we really need to get into distributed computing, is what I'm looking at. Okay, so I'm going to go into some foundational kind of talk first, agentic and multi-agentic. But first of all, too, like basically AI, right? And looks like maybe not everybody has been working with AI yet. So I wanted to kind of point this out. Essentially, to the left side is explaining AI. Artificial intelligence is the umbrella term that mimicking intelligence or behavior, pattern of humans or any other living entity. And then if you get inside this onion, then there's machine learning is the techniques that a computer will learn from the data itself. And then also, too, what actually makes it even more kind of useful is if you get into deep learning, and that actually will be techniques to perform machine learning that's inspired by our neural system in the human beings, too. So that's kind of like a quick way of explaining this. But as you can see on the right-hand side, I just want to take a look at how generative AI, which came out 2 years ago, actually, is it 2 years? Yeah, that's right, 2023. Yeah, so November, so almost 2 years now. And it's been capturing, a lot of attention and everything. And but if you kind of look at it, Gen AI is kind of really deep inside the deep learning side, but it also makes use of natural language processing. And that's what kind of make it more kind of, how can I say, like earth-breaking. Because before that, if you think of it, right, we doing computing, we have to send in our commands the way that the computer will understand. For example, even for some programs, we need to be talking like a computer. We have to say we want to do certain things. We have the name of the script, and then we'll have to pass in all these parameters, and even sometimes you have to tell it what type of parameter it is. It is a string, is it a number, all of these things, right? But with natural language processing, that's what kind of the breakthrough is. You can actually talk to the AI as if it's another person, just talk like anybody. So that's really a big, huge breakthrough too. So that's what it is. And Gen AI lives in the intersection of deep learning, LLMs, and also NLP in that layer. So these are just some of the generative models. As we all know, that's what is the ChatGPT now, is really the LLMs. That's what it's, it is very powerful, as you can see. All of these things, we are already using it, so without going all the details, we know that there are different modes, and these are also multimodal as well. You can do, spoken languages, text, audio, video, images, all of these things too. And then there are also platforms, generative AI platforms and apps like, Microsoft Azure is a big platform that basically integrated the AI capability into the cloud platform. And Amazon has SageMaker, for example, and Google Cloud has Vertex AI. And then there are plenty of other apps that we are all trying to build and compete with one another. However, now it kind of gets into this talk is about event streaming and multi-agentic and why agents, right? It's because LLMs, as powerful as it is, it has a lot of limitations. By itself, it doesn't have any memory. It can't keep track of the state. So if we don't have any programs to kind of help to keep the context, it's basically not very useful. You just can only ask questions once, like a one-shot deal. You ask questions and that's it. If you don't have any program to help it, then it won't remember. So that's LLM's limitation. And also the results itself is very probabilistic too, because all of these, they are based on fuzzy logic, and it's not, it's not deterministic. So it's a very non-deterministic type of algorithms that it has, which means if you ask questions 100 times, it can come back with 100 different answers, not exactly the same. So by that, it just means that we can only use certain LLM for certain things that you don't care so much about consistency. But then the world is kind of complex, and we need things that are more consistent, is what it is. And also, too, another thing about LLM is opaque. That means you can't add any attribution to its answers as well. But again, think of it as just a giant thing, and it remembers many things based on the data it's trained at, and it can, intelligently kind of strewn together the answers for you based on what it has. But then you can't really add any attributions to its answers or kind of modify it too. And not only that, another big thing with it is also very expensive, right? Very outrageous, the cost of it. So in other words, we live in a more complex world, and we're needing systems that needs to be scalable, that can also handle like workflows and data consistency and all of these things. And these kind of workflows that's where we kind of reaching out to kind of techniques. But if you think about it, we're kind of looking at agents, right? The agents are not new, and agents are already there. Even like in the times of like Unix beforehand, all of these operating systems. We're talking about all of these, complex tasks, and these are like different functions and a lot of agents that are already handling all of these tasks. And so, and not only that too, right? We need ways to kind of handle workflows, and also like helping essentially the program to remember the state, right? Especially for like enterprise level kind of usages. So that's when we kind of get into agentic kind of usages. So what is agentic architecture? It's basically that's the structure, essentially structure and design of AI systems that leverages on AI agents to perform tasks, right? So if you kind of think about it, for AI, it's basically we want the systems to be able to execute tasks, execute all the commands autonomously. So, and so now we're relying on the agents to do it. And not only that, they're also integrating with different kinds of tools. And also, too, I mentioned about like scalability. So we also want to have systems that, that the agents is able to handle. Like systems, when there are many requests coming in, it needs to be able to scale on its own, for example. And not only that, too, you also want the system to be very resilient. So if there are any problems that occur, you want it to be self-adjusting and fixing problems like that. So that's where actually agentic architecture can help to solve that problem. Okay, so some key concepts about agentic architecture. So if you think of, from an architecture point of view, you can have like systems that are having multi-agent kind of systems. You can have one agent that's the one that's like leading, right? That's kind of determining what to do, let's say. So that will be like a vertical architecture. And you can also have like horizontal architecture, which means you can have multiple agents, and that's actually the majority of the case. That you need, many systems too. You would need different kind of agents, and as such, agents each of them are very specific. They are doing certain tasks too that's assigned to them, and you need them to be collaborating with one another. Which means in that case too, you also need someone. So there will be another agent, is agentic kind of orchestrator to do orchestration as well. So essentially, you want agents to be able to handle complex tasks, and also like make decision kind of autonomously, and also be able to reason and even plan ahead of time, and that's kind of the ideal. Now, right now, there are many research being done on AGI, artificial general intelligence. So that kind of means it's agents that be able to reason on its own, but I think that's still some ways to go. It's not really quite ready yet, in my opinion. I mean, OpenAI might come out and say, oh, AGI is here, but it's actually not there yet. And as we know, and it's still making a lot of mistakes, it's still a lot of hallucinations, and it's just showing it's still got some ways to go. But that's the ideal situation is that we can leverage on agentic kind of way of doing things and help, having agents assisting in helping to reason things out is what it is. And then also too, another key concept too about agentic architecture is, being agents is basically, it has to be very adaptable too. So able to also transform their data that comes in, maybe certain things that happen, it needs to be able to adapt. So the adaptability aspect is also very important as well. And also, ultimately, what it means is that having agentic architecture is there are no human intervention. It's supposed to be. But really, that's what I'm saying is that right now, as we can see, even though there are chatbots and ChatGPT, all of these, we know, too, if you call into any kind of customer service, most likely, I mean, my experience too, and as we know, Dwayne, for example, my friend Dwayne, we fly a lot, right? And basically, I've also used, when we lost our luggage or something wrong with your flight, you actually try to reach your airline customer service. And I actually have done it in which I lost my luggage in London and trying to say, oh, I lost my luggage, just couldn't help you. So eventually, it just says, call a human agent to help, right? So I think it is showing that if you have any kind of situation that occurs in real life that's more complicated, that's not the cookie cutter kind of situation, then you will need a human to kind of help you solve it too. So anyway, we are moving towards the direction of having true agentic kind of way of doing things, but I think we are all moving towards there now. So, but it's just not here yet, is what I'm trying to say. Okay, so then let's get back a bit too into fundamentals of agents and agentic. So by the definition of agents, it's basically agents are the ones who is authorized to act for or in the place of another. So it's act on your behalf. It's like if, even non-computing situation, you can have insurance agent, you can have travel agent, all of these car agent, whatever. They are the ones that helps you. They are authorized to act for you in place of you or contacting another actual service provider, for example, is the agent. So likewise, in computing sense, it's basically, it helps us, these agents supposed to automate things for us. That's the goal. And then there's also agentic AI. It's basically software systems that use AI to pursue goals and complete tasks on behalf of users too. And it's supposed to have reasoning and planning and memory, all of these, a certain level of autonomy to it to make decisions and learn and adapt. And then no human involvement is supposed to be, but it isn't quite happening like that yet in the AI world. So Gen AI, so basically Gen AI agents then within software context, these are software entities that will help to orchestrate like complex workflows and coordinate the activities of multiple agents and process logic and evaluate answers and doing all sorts of stuff. So even, for example, I'll actually have a couple examples too. You can also have what they call like testing agent, that eval agents. They will be the ones that kind of critic whatever agents you're trying to do work. You actually need a counterpart of a critic agent to criticize, if the main agent is doing the right thing. It should be supposed to be testing it too. So that's kind of like the concept of such. Now then it gets into multi-agentic systems. So these are basically multiple autonomous agents working together, and each agent will specialize in different tasks very well, and orchestration is needed too. And also too, there are emerging agents too from agent interactions too. So in other words, we also want the agents to be smart enough to be able to look at a task and able to divide it up into manageable subtasks too. And then also, not only that, it's basically agents ought to also know its own weakness too. So if I don't have answers, I can be an agent and turn to another agent to get answers as well if I can't get the proper answer. And it's basically, we want these agents to be able to be very resilient and being like very robust and being able to kind of tolerate like fault situation too. Okay, so then now also leads to another thing as kind of jump into this now is basically talking about the protocol too. So in other words, we're doing agents. These agents in an AI context will be interacting with the large language models, the LLM too. They can connect to all of the resources the way they want, for example, to some database or to some external services, whatever it is. But then it always helps, right, to have some sort of standardized way. So that's when Model Context Protocol comes out. And they originated by Anthropic, the company that also makes LLM with Claude, right? And so they basically came out with MCP about maybe 7 months ago or 8 months ago, earlier this year. So MCP is an open protocol that standardizes how applications provide context to the LLMs too. So it lets you, build agents and also complex workflows on top of LLMs as well. And it's basically too, the current state as it stands is that they also, it lets you to build like integrations with your LLMs. And as you can see, there are also sites too that actually have people that are contributing to MCP server or MCP client that you can use as well. So, so let's kind of take a look at the next thing, which is another protocol. It's agent-to-agent protocol that came from Google, and it's been recently been also open sourced too, formally into the Linux Foundation as well, A2A. So at first when I look at A2A, I thought, oh, that's another protocol. But as it turns out, this particular A2A is designed to kind of complement MCP too. So if you kind of look into it here too, it's basically A2A protocol is a bit higher level. It's basically states the way how two agents should be communicating with each other. And then if you can see like below, MCP is dealing more with the infrastructural level. So they each kind of these two protocols, they handle like different levels of complexity between communication between agents and agents too. So as you can see, this one, the left side, you have your local agent like talking to, these different layers, and then MCP is talking with the APIs. And there's another agent too, is doing its own thing, connecting to another LLM, but between them, they are communicating using A2A protocol. So as you can see, this is how it works. Okay, and then these two, actually, I shouldn't be doing this one yet, but I'm going to go back to this, and I was just giving some examples of some events too when I get to event side. Okay, so talking about these agents too, this one, there's also a paper. I won't get into all the details now, but this one is actually from AutoGen, which is a Microsoft open source SDK for building agents too. And so this one, the AutoGen is actually particularly good, allows you to build like more like chat type of agents too. So as you can see, there's also a paper, and I'm sharing with you here in archive.org too. It enabling next gen like LLM apps, allowing for multi-agentic conversations in here. So and also too, it allows to this example too allows you to have agent that's also involving human the interactions as well. So that's what it is. So. Okay, so now let me get a bit too into agentic design patterns. And basically, there are four basic design patterns. These actually, I took it from reading about Dr. Andrew Ng. He's like a well-known figure. He started off AI Funds and also deeplearning.ai, the educational site. AI Funds is for the finance side. So he has a paper, right, that I subscribe to, and I read about these agentic design patterns. I thought it's very useful. Essentially, there are 4 design patterns: reflection, tool use, planning, and multi-agent collaboration. So over here, too, just wanted to talk about, now I get a bit into agent kind of design, right? So this is an example of a reflection type of design pattern. And so you can see, let's say we have a coder agent that's there to do coding. So it interacts with the proper LLM, most likely it's Codex, that particular LLM that deals with like coding stuff. So I can be over here as the coder agent. I'm taking requests, right, from the user that says, please write some code for some task. And then coder agent will go and work with the LLM and generate some code. Now, this is earlier, I talked about the eval agent. So over here on the right side is the critic agent. So this one will actually go through and look at what gets being sent back from the LLM. And it's going to criticize it and also find problems with it. And it will come back to the coder agent and tell it that, there's something wrong. For example, a bug on line 5, please fix it, and all these things. And then the coder agent will take it and then essentially send back that result and then tell the LLM to regenerate the answer, telling the LLM that it isn't perfect, this has some bugs, please fix it. So likewise, and the coder agent will then work with the LLM and gets another new set of code example that comes back. And then critic agent will then criticize it again and find some other problem. And so likewise, as you can see, it goes kind of through a couple iterations. So that's why this is called a reflection type of pattern. So that's something that agentic, if you are writing code, right, for agents, you can be leveraging on this kind of design pattern to help with this agentic design too. Okay, and then there's also another pattern too for agents. It's basically called tool use too, that Dr. Ng talked about. So essentially too, we can have agents like working with some LLM, and obviously it's taking some prompts requests from the user, and then it goes in and kind of do some answer, right, trying to like solve the problem. But then the agent also might realize that, okay, it may not always have the answer, the LLM. So in that case, then what you want to do is basically supply like the tools for the agent to kind of use, So basically, that's why it's tool use. It's basically, these are external tools that you can have the agent going to look up answers if the LLM doesn't have the answer for you. So in this case, it can be like a wiki page. For example, you can actually be configuring your agents to tell it to look up external sites, wiki page or some kind of dictionary site, whatever it is. And so like this, you kind of safeguard the agents will have some answer back for you. So this is like the tool use type of pattern. Okay, this one is basically, it's just a tool use illustrated from using like CrewAI. CrewAI is another open source Python-based SDK for building agents too. So I was just kind of like showing you in here as well. And CrewAI, it uses more of a role-based type of agentic approach too. So it has kind of slightly different type of usages scenario. Okay, so now I'll move on to the next pattern, which is the third pattern, is called planning. So it's just best to illustrate with an example. So for example, you want to be like requesting the LLM to generate, what I need is a little girl reading a book, but I will give the input an image of a little boy riding the scooter, but I want the LLM to basically look at the input image and then generate a different types of output. In this case, could be a girl reading a book using the same pose. So in this particular case is that we basically give all of these input and then tell the agent to determine, right, the kind of what steps will be needed in order to generate my final response. And that's kind of like the goal of this this pattern, particular pattern of using an agent too. So as such though, it's interesting, that was maybe 5 months ago when I was reading the paper. I think at that time, Dr. Ng was saying that in his lab, they tried to use the agent to kind of use this planning type of design, but he was saying that the accuracy rate isn't too high. But I think that's the kind of thing that they would like the agents being able to do, is to do this kind of like planning approach by learning from what's needed and learning from the input of a similar type for the agent to kind of figure it out. So this is another pattern, it's called planning. And then the last pattern is basically called multi-agentic collaboration. Now this one, I think, I have to admit that I haven't had time yet to kind of look at if there are any update to it. But as you can see, this is an example to illustrate. It's basically a true multi-agentic type of collaboration. And using an example of an IT project, you can have like different, for example, an IT project, you have designer that are, and also they give the commands, right, what they need over to the coder. So the coding team would be made up of like programmers and designers, for example. And then after that, they have reviewing team to do testing. And then also there are documentation as well, so different kind of roles. So as you can see, this can be quite complex to have this fully be automated using agents, agentic type of design. So over here too, they also have example of a chat chain too, that basically they can all be communicating through this chat chain as well in order to do the work. Now, so far this isn't like in real life yet, but I found it to be interesting that there's also a paper written on it, and it's on archive.org, as well as they have an example on GitHub as well. So I also have provided you with that link to this particular article that gives you detail of such too. So you can maybe also look into it if you're interested. So. All right, so I guess enough of all of these multi-agentic things. I just thought I should touch on it. And there are also a couple of multi-agentic libraries that if you're interested, you can look into it if you haven't already. Again, I mentioned about AutoGen from Microsoft, and then CrewAI from the Python vendor, and LangGraph from LangChain. And also there's a relatively new one from AWS, and it's not just bound to using, on AWS too. It's called Strands. And this one allows you to also build agent library. It's primarily Python. It also has it in other language as well. And then there's also, Google has an agent SDK. And if you're Java developers too, there's Quarkus, and also the Quarkus LangChain 4J integration as well. So those are a couple of examples of these multi-agentic libraries. And then there are also a couple of examples too that I've provided you here if you're interested in looking. And so I'll be sharing this slide deck afterwards too if you like. So, okay, so now, let me, all the agent stuff, and let's kind of get a bit into some popular AI agents, because what I've just talked about is more about we're going to be writing a bit more serious if you're a developer developing agents that are a bit, serving something, scenarios that are more complex. But for today, we have all of these like popular AI agents that are no code or low code too. So these are mostly for non-programmers. Just wanted to kind of point out a couple of these, right? There's ChatGPT, I guess without saying, everybody knows, and they have also like offer like multi-agentic libraries in there, and also like relatively easy for non-programmers to use. And then of course, Microsoft has Copilot as well. And these are also somewhat like easier, doesn't require any kind of programming background to do it. And then Google used to have Bard, but now it's updated the name to Gemini. And also there's another one that's interesting. I look up, there's Replica too. Replica is you can actually set up yourself, and then, but unfortunately you do need to pay for it or give your credit card. And then you can kind of handle like Replica to be interacting with it, and also like basically handle some of your emotions too. Is kind of interesting, I think, from that perspective. And kind of you can be telling it about how you feel and see how it kind of helps you and respond to it too. Anyway, but that's what it is. And then there's also Notion too. If you are using Notion, it can keep notes and do a lot of the day-to-day things in a project management type of things too. So these are just a couple of these multi-agentic libraries too that you can use a bit more of, kind of not for further developing code. It's just for you to end user type of agentic libraries. Okay, so now I'll get into a bit event streaming, then event-driven world, and AI. So, I'm just assuming some of you may be developers here, so I will have to talk a bit too about this side of things. And so basically at the heart of AI is really the data, right? So without data, nothing will happen. And of course, data also involves the flow of data in many directions too. So working with data and tools, on the architectural level, you can have event-driven type of architecture. And then I also wanted to point out too, when we work with data, we have to be aware too, data can be in different states too, meaning that it can be at rest. At rest meaning that it's in storage, in a database or file systems or any kind of place where you have data be resting, right? It's not doing anything. It just sits there, it's bytes and bits and bytes in your system too. And then there's also data in transit, and they are think of it as in transit is during like network communication, the nodes, when we're talking about messaging, when we need to send data from point A to point B, different nodes, and that's actually happening all the time as we can tell, right? That's what it makes things interesting too. And so those are called in transit, and then there's also in use is when you extract, let's say extract data from some database or data file, data source, and you want to be manipulating data. For example, you have an order entry, right? You enter the order into your database first, and then you need to update your order, the pricing, whatever it is, or maybe the state of this order. And in this particular case, it means data will be transformed during that time. So now then, there are also different techniques to handle them, and that's when we're talking about event streaming. So think of let me kind of first talk about it first, like event streaming. Let me actually talk about event messaging first. So when we talk about messaging, is basically, message is you want to have some data sending from point A to point B. So all these two I'm listing in here, there are different software that you can use. For example, Apache Kafka, Pulsar, Red Panda, for example, Solus, and these are just a small handful, and some of you are using Azure Message Hub, for example, all these, and AWS also has their messaging hub. And then there's also another techniques called event sourcing and CQRS as well. So just want to kind of go back a little bit now. The event streaming is basically, we're saying that stream as such, we're describing data is happening, the messaging part is happening all the time. Data is traveling. The streaming it can be happening at any time, traveling from point A to point B or to many nodes as well. So that's streaming. Is a continuous kind of describing of the flow of data too. And then there's also messaging. So messaging, it can be using like techniques such as publish, subscribe type of system. So as such, right, for example, if some of you work with Kafka or some message hubs, then we are talking about their message producer. They are the ones that will be sending messages, but yet they don't worry about who they send to because it's actually the broker in between that will be handling, receiving the data from the producer. And then if you are interested in the data, then it will be the client that's interested in the data and subscribe to that message. And in Kafka, the terms is using a topic. So the topic label your messages. So if I send messages to the topic and I'm a client, I'm interested in that topic, I'll subscribe to it. Kind of think of it like a magazine. I'm subscribing to some magazine. When there's like that issue comes out, the magazine will be sent to me, kind of like that kind of concept too. So that's event messaging using PubSub. And there's also message queue as well. So queuing is more like, think of it first in, first out. So it's just a queue. So if I have messages that comes in, I put it into the queue. And so and then there are more messages going into that same queue, but every time it will always be the first one that gets in will be the first out too. That will be picked up by the client. Once they are picked up, then they will be gone. Or unless you also save it too. That's the idea. So you can have queue or event messaging like that. And then in the old style, there are also messaging that are such as IBM MQ. All of these are also like queuing type of mechanism too. So all these two I just want to talk about because they're actually really fast, and also they decouple your sender and your receiver. So it makes the scalability to be very, very good because you can scale things without worrying. They are not coupled together, so you can scale it much more easier. So that's why we're promoting that too. Now, there's also techniques such as event sourcing and CQRS. So that I wanted to talk a little bit about because event sourcing is basically, now I'll use an example of an order entry. So in typical scenario, you're using a database to keep track of, let's say, an order entry system. So the order comes in, I can have, order number 1, and order number 1 has, I've obviously have a state kind of column to describe it, right? When an order comes in, it's new, and then some agent pick it up to process it, it will turn into process. And then, and then during time, it could have on hold or whatever, right? The state changes. Now, you doing it like that, then it's okay. You can always search for the last status of your order. But what if there are some problems? I want to go back in time and look at how the order has changed. So that's when we want to use an event sourcing kind of mechanism in which, in this case, we're trying to log the state changes of this order. So in other words, we'll have at each time the order changes in state, I'm logging a record to it. So it's true, we're going to keep a lot of different records about this order, over the lifetime of this order. But the good thing about it, if there are problems that happens, I can go back to do replay. And let's say, this order had this certain time, I'm going to go take a look, every state changes is all being logged like that. So that's what event sourcing is. And there are also CQRS, which is command query responsibility segregation. It's a pattern that basically you separate out the writing of these events and then also the reading of the events in order to make the processing to be very efficient on the reading side as well as the writing side. So that I won't get into all the details, but just want to kind of point that out to you as well. So all these Kafka and Pulsar, they also support that as well. And there are other systems, too, such as if you're familiar with Lightband, a company called, now it's called Akka. Akka makes use also another messaging systems that makes use of actor model, too. If you're familiar with that, that's also very strong supporting this kind of pattern, too. Okay, enough of that stuff. So let's kind of get back into Gen AI kind of streaming usages. So just wanted to point out too as such, right? If you kind of look at it, I think event streaming is everywhere. It's just not maybe being talked about out in the open as much. But if you kind of look at it, Gen AI, right, this kind of usages, we can have prompts, right? Prompts can come from the command line or through from the browser, from different types of devices or mobile apps too. So these are, they are every time you're sending messages over to your LLM, that's actually, they're streaming, you can be streaming. It can, anybody can be using their phone and submit any kind of prompts to the LLM, for example. And then Gen AI also have intermediary steps too. So in the case of a RAG operation, right, like retrieval augmented generation types of operations, then we are also talking about you need to be getting data from external sources, all of these, and you can also be leveraging on streaming to do that too, such as from an external database or a file system, or some kind of TCP/IP socket and things like that, more lower level, or message queues or Kafka topics as well. And then of course too, then you get all the data, then you need to augment your prompt and send all the requests over to the LLM. That's also another streaming type of scenario that you can kind of be aware that you need to be using some mechanism of sending requests over to LLMs. And then, of course, then from Gen AI, you also get the output, so the responses will then be sent from the LLMs as well. So you also will have to handle the results that are coming back from it as well. So now, kind of getting into it is the benefits of the event-driven approach is basically, as you can see, this event-driven approach is good because the nature of data is very dynamic. The flow pattern is dynamic too, so it handles it very well. And also too, not only that, right, you can also have data that's being sent continuously or at any time, so very asynchronous too, through event streams. And this helps, again, the very decoupled, loosely coupled type of components. It helps with scalability and flexibility as well. And it also, too, in this case, right, we're kind of looking at, you can have agents that are working with LLMs. You can have the whole ecosystem have multiple agents, and I can have agent that's working with a coding specific LLM, and another could be working with another, an audio LLM, things like that. So you can have different LLM or different agents working with different LLMs, and it helps too with integration of these different kinds of models and agents working together. But also at the same time, we just have to be aware of the challenges. If you're using any kind of event-driven approach, it tends to be harder to debug because now you are handling data that can be coming from, at any time and coming also a bit in an unstructured type of format too. So it's maybe sometimes it can be harder to track the flow of your calls or the data it carries, all of these things. So just have to pay more attention to how you handle observability side of things. Okay, so now then I'll get a bit more then into distributed computing and agentic data, AI too, for data engineering. So this part, maybe I get a little bit more into this, but I feel to have agents to be truly kind of really useful, we have to kind of start thinking about this. It's basically CAP theorem. So not sure if some of you have worked with CAP theorem, but it basically stands for consistency, availability, and partitions tolerance. So these are essentially the three fundamental aspects in distributed computing that works with data. So essentially too, for data, right, we want data to be consistent. So which means data, every read of your data has to be the most recent read, right? From the most recent write to. So it's the latest, updated, is consistency, what we're trying to get at. And then there's also availability. So basically, you want every read to your data, you always get back a response, but not necessarily the most recent write to. So meaning that at times you can have partitions issues. So partitions is referring to the network condition. So you can have like partitions that's actually disconnected. Somehow your network is fail. There's no connectivity kind of issue. So now this is where the theorem is. It's basically saying that these are three fundamental aspects of any distributed systems that works with data. But the truth of the matter is only two of these aspects are guaranteed at any time, because you can actually have partition tolerance and there's no network connection. At that time, then what will happen is, do you choose consistency or do you choose availability, right? All these things, or let's say, right, you have problems, there's partitions tolerance, and most likely too, if there's network connection, then basically you get back the response, and also the consistency should be very high as well. But anyways, this is what it is talking about. The CAP theorem is saying that only two aspects are guaranteed, right? So that's the thing. So if you kind of look into this, and why I kind of want to mention about it, because the databases that we have in the market these days, they are not respecting all of these rules too. Some are, for example, like I think, for example, RDBMS like Oracle or MySQL, all of these, they tend to be more consistent, they're more consistent. So then sometimes too, they may not be responsive to if there's a network disconnected, right? There's no networking, and that's what happened. But yet, some of these other databases, Mongo database or Redis or Hypertable, they tend to be a bit more, I think one of them, actually which one? I think it's, well, actually, system is functional, yes, inspect of network partition, meaning there's no, there's problem with the networking, but I'll always get back a response. But what I get back may not be a consistent response. Like I can be, I always will get back a response. But even though there's no networking, the network isn't up, then I'll get back the data that may not be the latest. So it's not very, it's available, but it's not the most consistent. However, there's also this theory of eventual consistency, meaning that it doesn't matter, because eventually, when network is back, then I will be getting back results that's consistent. So that's what is eventual consistency is. So why I'm mentioning about this is that, you have to, if you are designing database, your situation, you have to think of the kind of database that you want to use and see what is more important to you. Is it more important to have consistent data, or is it always being responsive? So that's why this kind of comes into play when it's dealing with distributed data. Okay, so then and another kind of thing I want to point out is Pascal. This one is an extension to the CAP theorem too. So essentially, it's kind of saying that it brings the CAP theorem to another level. It's basically saying that even without partitions concern, then consistency and availability would still need to make some compromise between the two because you can't just have all, basically, that's what it's saying. So let's say, you have partitions tolerance is, then you network is connected, you have available data and is consistent. Otherwise, too, you have to choose between the two, right? Latency or consistency. So that's what it is. So again, it's more theory. Now, in how Pascal is reframing Gen AI in this case is that for Gen AI, so it's basically the else part will dominate. So users will expect, actually in Gen AI case, you always want speed, right? You want data to be available. So there are streaming tokens that are sent over. So you cannot tolerate the fact that there's a gap in your responses. So then it will basically push you to low latency reads for Gen AI type of cases. And it's basically the else part will dominate. And then often too in this case, you don't care so much about consistency. You want to get back the results because you believe there will be eventual consistency. And these are for Gen AI type of scenario. So, okay, so that's that. So that was real quickly. And also, too, just a quick thing, too, about CQRS and agentic AI. So basically, CQRS I already talked about is basically a software architecture pattern. It separates out the data model being used for writing commands and also reading queries, too. So it does impact like data storage requirements as well. And it's basically for agentic AI systems too, they very dynamic type of use, right? So more serious type of agentic end-to-end enterprise level systems, then the CQRS will really make a lot more sense, is what this is trying to say, so, okay. All right, so now then gets into more of the cloud-native principles for AI workflow. Just wanted to mention a few words too. It's basically for any kind of cloud-native when it comes to it, we're talking about containerization and orchestration as well. So obviously too for Docker, that's helped to containerize, and then Kubernetes will come into doing orchestration as well. And then if also too, you may want to. It's actually interesting too for microservices. There's actually been talks too about how agents are essentially microservices in a different forms. Which means like agents, and also in the AI context, it's not really new. It's basically, essentially, agentic AI is essentially microservices in a different form, and also serving for the AI kind of context too. So that's kind of like in this respect too. And then also too, there's also CI/CD that's we have to kind of also think about, and also managed cloud services too. So anytime we're talking about cloud, using cloud native type of systems such as Azure, right here in Microsoft and Azure, you can also think of when you're having agents that are a broker, all of these things, you can actually have your managed cloud services be hosting your broker that actually also will have built-in monitoring and security kind of built in for you as well. So that's the cloud thing. So now we kind of look at some popular frameworks and toolkits too. So it's trying to achieve more like a language agnostic. But let's say I work more with Java, so I kind of naturally will mention about Java. So there are also cloud-native SDKs such as Quarkus or Spring AI or LangChain 4j. How many of you, I'm just curious, work with Java in here? Do you have folks? Yeah, one or two, yeah, two. But I guess mostly probably not. But like I said, because I work with Java, so I mentioned about it, but still very useful too. And then with Python, LangChain or Ray or Prefect or Fast API and Celery too. These also are kind of popular Python. And then for JavaScript and Node.js, you have Node-RED or Nest.js or Next.js and Vercel as well too. Okay, and then also too for again for cloud kind of necessary, right, for doing AI types of applications, scalability, observability, and resilience strategy. It kind of remains the same. It doesn't have to be just AI apps too, but we want to kind of emphasize again, right? You want cloud system to be provide the fault tolerance to it, and also doing event replay. And again, that event replay too, I kind of want to mention, right? Especially for event-driven type of installation, you might want to consider using event sourcing too. That will also help you with event replay. And also there are distributed tracing, and especially in cases in which you have multiple agents, they all are in different, maybe they can be in different servers as well. So you have to also make sure there are also distributed tracing. And in cloud systems too, in general too, they may also have like distributed tracing capability. And also horizontal scaling in a cloud system that has the scalability that's built in, auto scaling, all of these things. And observability, you can be thinking of using tools such as Prometheus, Grafana, OpenTelemetry. These are like cross ecosystems too. And one more thing is basically also very important too in AI type of systems, actually most important, not just for AI, but anything, but especially for generative AI systems and agents too. I don't think there are any truly very strong security type of systems that can ensure agents are fully safe to use. But we are working towards that, making it better. But I wanted to point out too, for cloud systems, you want to secure, especially if they are distributed AI systems too, you want to make sure the cloud infrastructure can provide the security that it needs, and also managing credentials, and also in some cases you can have multiple cloud servers too that you want to be compliant. And also, not only that, they're supposed to be also like responsible AI governance as well. But I don't think, to this day, I don't think there are any true kind of governance that govern how AI, ought to be, the ethical side, the safety side. I think it's still being worked on. But in other words, I think, the cloud infrastructure should take part in enhancing or supporting all of these governance side of things for AI. Okay, so now the last bit of things just wanted to talk about too, kind of go back to event approach, to kind of retrieval, using it for retrieval augmented generation, because I mentioned it briefly too. So RAG, right? So what is RAG? Just quickly saying that they have actually, in the development world, has become kind of RAG is like the de facto thing you use when you're developing generative AI types of applications, because it's essentially, it augments what the LLM doesn't have, right? Because we're talking about, we train the LLM with certain data, huge amounts of data, but it's always lagging behind because it takes a long time to train to get your LLM ready. So the data it takes from is always older. So then the time lag between then and now, there are plenty of, a lot of things happen. You need to take into account what's up to date, real-time data. So that's when you use a RAG technique, right? So essentially, RAG models are made up of two components, the retrieval and the generative model side. But let's kind of take a little quick look too. And again, we're talking about using like event streaming type of approach and kind of applicable for RAG. It's very kind of applicable too. As you can see, right, this is a diagram that describes what RAG is, in a simplistic way, because I'm not getting into some of the nitty-gritty of doing a RAG. But at least two, primarily, step one, you have user submits a prompt to the RAG application. And the RAG application, in this case, it will then also retrieve data, relevant context from some vector data store, because this is going to supplement or augment what the LLM doesn't have. Right? Some of the private data, for example, from your company, that's a legal firm, a hospital, for example, these are data that's not being trained in the general LLM. So I take that, and basically then I augment and enhance my prompt. And then with that, then I will send the prompt and relevant context to the LLM. LLM will then decipher what your prompt is, and with all of these added context, then it will send back to the user the results. And this is, again, just kind of like, minimize or simplifying this whole picture, because as such, right, when we're talking about RAGs, you can be in a company, especially, for example, like, a hospital system, you can have data that's a lot, so much so that, there's also limitations of how much an LLM can take at one time. So you have to then chunk and divide up all of your data, right? And essentially have all the RAG data comes in and you want to like divide up and using the strategy called chunking. And chunking is another talk of itself because there are different techniques to it as well. And also when you divide up your data, you also want to make sure it should have like overlapping area where they, kind of like when you divide them up, because then otherwise if you don't have the data properly sent in, and it can come back wrong too as well, right? The results like that. So all of these chunking, I'm just trying to point out, it's also another level of complicated thing to it too. And not only chunking too, there can be filtering or any kind of other kind of techniques that you need to be considering, but it's not described in here, but this is hiding what it's supposed to be. So that's the kind of thing I want to talk about. So basically, the role of the retrieval model is basically, it acts as like a specialized librarian. It will pull in all of these relevant information from an external source, and then it gets fed to the generative, well, actually, then it goes through everything, and the LLM will come back with the initial set of data. Then the generative model will then act as the writer, and it will craft up some context that's kind of more, coherent and more informative, and make it sound even better too, and making it contextually rich. So these two, the retrieval and generative model, they work in tandem with each other to make, for example, you're using an LLM to write an essay, it comes back very beautiful because the generative model side will beautify it for you like that. So that's the idea. So this is kind of role of the generative model, which I just talked about. Okay, so now kind of gets to the end of it, but basically just wanting to point out too, I know we talk about event streaming, but primarily to the AI, the Gen AI side, we just have to be aware of these challenges and the issues too. These are, we're dealing with complex system design and coordination. And also, too, we're now talking about multi-agents. They are essentially distributed agents. They can exist in different, network boundaries, right? They can be different servers, all of these things. And also, too, that being not the same together, so you have to kind of ensure that data is consistent and is accurate, too. But of course, now we're working with LLM. LLM is by nature is non-deterministic, so it's actually can be a challenge too, and that's why we're seeing hallucinations, all of these things. So in other words, like the agents itself also should kind of take responsibility for enhancing or helping the results to be a bit more, moving it more towards deterministic too, as much as possible. And then there are also like latency kind of issue or resource usage. We want to make sure it's optimized to this aspect. And not only that too, like working with LLMs, Gen AI, is basically there are sustainability issues, meaning LLM is still energy hog, right? It uses a lot of energy too. And I think it is getting better now, for example, all of the GPUs of the chips manufacturer, but still it's not eco-friendly at all. It uses a lot of energy. A lot of the data center already seeing a lot of energy being used when we're using LLMs, using ChatGPT too. And there are still hallucinations in Gen AI with the LLMs. And also, too, this AI safety and responsibility, responsible use of AI is still something that I think the whole world is still trying to work on. There are ethical aspects and potential misuse, too. And also, not only that, we're talking about prompts, right? There can be prompt injection that somebody could be, you sending prompts, and there could be malicious thing that comes in the middle and inject some problems, kind of wrong things to it. And not only that, right now the agents also is not very safe. I think only recently I started hearing about MCP server having more security kind of starting to be built in. But I'm also kind of questioning too of a lot of agents too. How can we be sure that an agent can actually take certain data and then process it or whatever, and then send the data back to the requester? How about, we don't even know if the one requesting the data is allowed to be looking at certain data as well. All those things I think needs to be still to be resolved, and guardrails needs to be built in. Okay, so I think then it will come to the end of this talk, but just wanted to share with you the slide deck. If you're interested in it, it's here. And yeah, I'll leave it a few seconds. Yeah. Okay. And then there are also some information too on the paper. This one, the AutoGen one, I have the archive.org paper. It's actually, on this slide deck too, I also give the link to the 4 agentic pattern. There are also the deep learning links there too, but I didn't list it out here, just so you know. And then a couple of the OSS Insight collection about the different agentic libraries. And also I wrote an article on Java Advent Calendar. And that actually will give some specific like event streaming, but they're a bit more specific for Java, how you do like event. I have certain examples of event types that is basically can be used to. Okay, and I also have this Twitch channel, although I have to say I still have not found time to do it, but otherwise too, I'm on Twitch if you want to follow me. I'm still trying to restart my Twitch at some point. And then with that, I want to thank you again, and thank you to Eric and David and, for hosting me tonight and inviting me to talk here. And this is how you can get a hold of me. If you have already scanned, yeah, then you can get a hold. Thank you so much, yeah, everybody. Thank you. I'll let you.
All right. Thank you so much.
Thank you, Eric.
Thanks everyone for coming tonight. As a reminder, Tuesday, December 9th, that will be our last session, our last gathering for the year. But it will be a session on what isn't your system supposed to do. So distributed computing concepts, things like that, and things that you shouldn't be doing in your systems. So that should be pretty interesting, and then there will be a lightning talk ahead of that as well. I don't know what the topic of the lightning talk is.
I wrote it down. It's in the, I put it in the meetup.
Okay. Oh, perfect. I remember that. Yes. So I'm looking. Leveraging AI for cloud optimization. So that should be interesting too. So please come back and join us on Tuesday, December 9th. Same time, same place. You can register on the meetup. We'll need to register so that you're on the building security list. And as David mentioned, make sure your first and last name is in there so that they're not calling David all the time. And we should have pizza and all the good stuff as usual. If you are interested in presenting, or you know somebody that might be, or you have, maybe you don't know this person, but you think they might be a great presenter for our group, topics on cloud computing related things. It doesn't have to be Azure. I know a lot of folks in here are Azure folks and Microsoft centric. But it could be Java, it could be AWS, GCP, something else. That's totally cool too. We want to hear about all the cool stuff out there. So please invite them. There's a Sessionize link that they can submit to as well. Student Sessions, where you can just message us through the meetup as well. So feel free to do that. We'd love to have all sorts of great contributions and interesting sessions. So with that, thanks so much. I think there might be a little bit of pizza left and some brownies and such as that. So feel free to hang out for a little bit. And a lot of salad. Okay, a lot of vegetables left. One of the things that we also want to do is part of this group is not just show up for great sessions and content. While that's great, we also want to just get to know folks in the room as well. Not just me and David. I'm talking about you all. So feel free to hang out for a little bit and chat and meet folks in the local Chicago tech community. So thanks so much.
Thank you.
Yeah.
Thank you.
Sure.
Oh, yeah.
You can.
Sure.
Yeah. Go fire away, Dan.
Dan, I work for McDonald's.
What do you do at McDonald's?
I work on
Is there a microphone? Then
Oh, is there a mic that we could pass?
That's right.
Oh,
Then
yeah,
we
we
can
got this.
do that. Yeah, just make sure it's turned on.
We can pass around.
Should we? You've probably done, right? Or should
I'm Dan. I work for McDonald's. I work on live events internally.
Oh, nice.
Hi, I'm Marta. I am returning to IT after over a decade.
Hi, I'm Akash. I work with Microsoft. My team takes care of Azure Storage, Azure Compute, and Azure IDC services for backup and migrate all the content.
Good evening, everyone. My name is Kamesh. I'm the founder and CEO of Accurate Consulting Group. We build agentic AI and Gen AI applications and solutions. Thank you.
I'm using SAS a lot and using analytics data, so that's why I'm interested in data analytics, and also AI. And furthermore, it's like quantum computing.
I'm Dwayne McDaniel. I'm a developer advocate at a company called GitGuardian in the security space, where we make an internal use of LLMs and end up talking about LLMs and AI quite a bit from stage.
Ivan is my name. I work as a software engineer, mostly backend in .NET, ASP.NET Core. At Noda, it's a payment provider, and I do some backend stuff.
Broker the mic from one side to the other.
Hi, my name is Alex. I also work for McDonald's. I focus on enterprise integrations, so the event streaming topic really piqued my interest. So.
Sure. Oh. Sorry. Yeah.
That's all right.
Thank you.
I'm just gonna walk all the way to Jay down there.
Yeah.
No, I see.
Oh.
All right, my name is Moaz. I am a software engineer. I work as a front-end developer. This is my first time joining the event in this awesome group, and I think I'll be here more often. Thank you very much, and nice to meet all of you.
Thank you.
I'm April Rains, and I work as a consultant for Eric at ResponsiveX. So,
That's my son Jackson as well. So.
Oh, your son. Nice.
Hello, my name's Jackson, and I am a trainee for my dad.
Oh, nice.
Hi, I'm Judy. I'm a data engineer currently I'm open to work. I've worked with streaming. I'm very interested in AI, so that's why I came to check out this presentation.
Hi everyone, my name is Max, and I'm currently pursuing a master's degree in computer science here in UIUC, and my program is located in Chicago. Yeah, and I do have some experience using AWS and GCP, so that's why I'm here. Thank you.
I'm Drishti Arora, and I'm a graduate student at DePaul, doing some cool projects in the field of data science, AML, and here for some good networks, meaningful connections.
Nice.
Hey, I'm Sam. I work as a data engineer, mostly Azure stuff, but then I'm moving from more of a batch processing to streaming world of things, so I've been using like Flink and Java and Python. I think they also have a new Flink agents framework. That's interesting, but yeah, that's pretty much about me. Thank you.
Hello, everyone. My name is Jung. I'm a consultant at Cisco, and lately I've been doing a lot of work in the area of competitive intelligence and prompt engineering.
Hello, everyone. My name is Afroz. I recently graduated, so I'm very new to all of this. So I'm just here to learn network and, yeah.
I will get the mic down to Jay.
Yeah, you're welcome. Hi, my name is Jay. I'm an IT consultant. One of my contracts is with Telnex. It's a telecommunications company.
Nice. Thank you. I was looking for an email that I had. So I heard a couple of folks in this in the room are currently seeking opportunities. So the folks, I don't know if you guys are familiar with Relativity or K-Cura, Chicago company in the legal industry. They reached out a while this month and asked if I could mention that they are hiring. I told them if you buy pizza, then I would be happy to mention that you are having a hiring event. But it would just be a disservice to you all if I didn't mention it either way, even though they're not buying pizza. So they did not buy pizza, by the way. But if you go to careers.relativity.com, they have some openings, but tomorrow they are actually hosting an event Engineering the Future Generative AI Hiring Event. So if you search for Relativity and Engineering the Future Generative AI Hiring Event, I'm sure you'll find it. But it's an event that you can sign up for and go check out tomorrow at their I think office here in the Loop. So cool. A cool company. What they do is really cool. And so it's. I thought I would mention it just because I heard some folks in the room saying, "Hey, I'm looking for cool new opportunities." So, and I know today's job market can be a little tricky. So I thought that might be useful for y'all. Yeah, definitely. If you go, tell them that you heard about it from this. Okay, let them know you heard about it here, and you heard they didn't buy pizzas. What is wrong? Yeah, come on. Yeah. So, all right. Well, thanks everyone for coming. Hope to see you guys again soon.
Thank you. Thank you. Thank you. Thank you.
Thank you so much, Mary.
Thank you, Eric. Thank you, David. Awesome.